Okay, you guys can see my screen? And I want it to be also interactive. So if anyone has like a question or anything like that, wants to stop any and raise your hand, then I would love to answer any questions as we go through it. Is this bar is kind of blocking the presentation a little bit or no?
It's
Okay, you
clean.
can
No.
explain. Okay. So we're gonna talk about AI agents today. So we're kind of trying to demystify it because there's this idea that like agentic AI and generative AI are like two different things, and agentic AI is like this special AI thing that's like off in a vault somewhere that uh, they need superpowers to access. But it's really not. It's the same AI that everybody's using, but it just has some different features to it that give it some additional capabilities. So you guys can see this whole slide, right? Okay, cool. Let me put this down.
Yes.
Okay, so the main components of an AI agent that differentiate it from the normal generative AI that we use on a day-to-day basis are memory, tools, the prompt, and then the model is the same models that you're used to using. So ChatGPT that you're used to using is going to be the model that drives these agents, or Claude, or whatever language model you're using is going to be sort of what's behind these. And so we have this. Has anybody seen this movie Memento? It's like the guy that he can't remember
Yes.
anything. I think I don't know if it's like whenever he goes to sleep, he has no memory basically. So he has to write everything on his body in order to remember it, right? LLMs are the same way. So even every single time you send off a chat to ChatGPT, it has no memory of the previous thing that you've said. There's no intrinsic memory in LLMs. But what happens with LLMs is we use databases to give them context about what we're talking about. So when you talk to ChatGPT, it will pull in every single time you send off a question or just continuing a conversation with ChatGPT. It has something called short-term memory and something called long-term memory. And so short-term memory is going to pull in probably the past 5 or 10 most recent chats you've had with the LLM into that into that question that you send off. And then long term memory is going to go off to a database that has long term information about you. So your name, your goals, all that kind of stuff. And it's going to pull that information from that database. And so I'm going to open up. So we have short term memory here, long term memory here. And I'm going to open up a database so you guys can get sort of an idea of what this looks like. So this Superbase is a database. It's used for a lot of different AI apps. And then what I'm going to show you guys in this base is sort of what a short-term memory database looks like, and also a long-term memory database looks like. So you can see what actually is happening when you're talking to these LLMs. So here's a photo of what a long-term memory database is, right? I told my LLM at one point I like chicken. And so it's going to store this information that I like chicken, right? And so when we have a conversation, I send some information off to it. It's going to pull that information. It's going to know, okay, he likes chicken, right? So if I ask for like a dinner recipe or whatever it is, it'll say that. But you can start to imagine, when you're talking with ChatGPT or Claude or whatever, these LLMs that are familiar with you, they have probably hundreds of lines like these. So they'll have things for your name, your birthday, all that type of information is living in a database somewhere. And that's how it's able to have this sort of familiarity with you in conversation, where it knows this these long-term details about you. So this is sort of what a long-term memory database would look like, obviously with a lot more rows in it. And if we go through this database, we have an identifier. Just this is a unique identifier, just so that we can separate the rows, identify each rows using some sort of a key here. We have the actual content here, which is the fact that it figured out about me is that I like chicken, right? And then we have metadata, which is information about the data. This isn't super important. It just gives us some basic stuff like the timestamp, the sort of like the type of code that this is, that kind of stuff, right? This metadata about what we're putting in here. And then this is where things get interesting. So this is an embedding. This is how AI stores meaning. So AI understands meaning as math. And what we have here for every, let's see if I have a better example here. Okay. This is So for all the text that we have that goes into AI, it encodes that meaning as math. So let me see if I can try to find like a vector store um, image demo. Okay, there we go. So you can, if you see this image here, right? You can imagine like a three-dimensional space where banana is close to apple in that three-dimensional space, where wolves and dogs and cats are close to each other, right? King and queen would be close to each other, all that kind of stuff. So it's not storing the, when it gets this text, it's storing the mathematical like place in space that that text would exist, and it understands the relationship between content that way. And so this is a visualization, but it's really an oversimplification because this is three-dimensional space, right? We have an x-axis, we have a y-axis, we have a z-axis. It's 3D, right? But when AI stores meaning in terms of embeddings, it's not going to use three dimensions. It's going to use, I think OpenAI uses 1,500, 1,536 dimensions or something like that. So it's not three-dimensional space. It's 1,000, 1,500 dimensional space, right? So it's all these different dimensions that can encode um, a lot of depth of meaning for this concept that we put in there. And so what that looks like from a database standpoint is that when I put text about me here, right? This is my major goals, my vision, all that kind of stuff. It's going to encode that as a vector. And so each of these number points are like coordinates in space. And we can see here, this is going to have like 1,000 plus of these different numbers. It will just keep going and going and going. So what the AI understands is this, these embeddings, and then it can use math to see which embeddings are close to each other in space. So if this is close to this, it means the content is similar, which means that if I'm talking about my goals here and mathematically this row is close to this row, then I'm probably talking about my goals again here, right? And that's kind of how AI understands um, the the meaning of text. So that's embeddings. And then we went over long-term memory, but there's also short-term memory as well. And short-term memory is going to be the actual content of your conversations. So here's the actual conversation that I had with the AI stored in a short-term sort of memory base. That the AI, when we're having a conversation and back and forth, it will pull in this entire context so that it understands what the conversation is about, right? And the when we open this up here, we can see the type of message, which means that this came from me, the human, and the content of the message, which is I really like chicken, right? So you get that message, which is what I said to the AI model, which is then what it used to create the memory that the user really likes chicken. So we have short-term memory that looks like this, and we have long-term memory that looks like this. And this is how AI generally stores or can give off the feeling of having memory because it doesn't actually have any intrinsic memory about anything or anyone. It just pulls information from databases every time we talk to it. So that is component one. Does anybody have any questions about memory stuff before we go to the next thing? Okay, cool.
Absolutely. Hold on.
No, yeah.
So let me ask you this.
Yep.
If Are you saying, right, that rather than purchase an agent, we can actually teach regular chat GPT to become an agent? So what I'm asking is this. Let's say I'm creating a digital twin and
Yep.
I give it my resume, right?
Mm-hmm.
And then I break down each section of the resume. Like the resume is just static information, what I did, when I worked, and whatever. But if I go deeper and tell it the reason I chose that job because of what I love and give each section a reason why I love that job and save it on a database, I can train ChatGPT that anytime there's a discussion about Sebakunzi, it goes to the database to understand what he did and why he did it, and then can now fill in forms and everything else based on what's in the database.
Yeah. So I mean, absolutely, you could do that yourself. The
Oh, yeah.
good thing about something like ChatGPT or Claude or these things is they handle a lot of that for you, right? So it's the same sort of architecture where you have, if you go to ChatGPT, there's a database in the back end. You can't see it, obviously, but that's storing information about you during your chats, right? And it's storing your chats as well. And that's how it's able to sort of maintain this continuity between different conversations. But if you wanted to do that from scratch, you could also do that from scratch. You could get your own database. You could get your own language model. Like this is sort of what people do in more regulated industries, whether that's law or medicine or whatever it is, or finance, right? Is you'll build out your own agent from scratch where you get a language model, you control where that lives, you have a database, you control where that lives, and you'll control sort of the tools that you'll give it as well. Okay. So that's the memory, right? We have short-term memory, long-term memory, and both of those, they're just databases with information in it that's going to be passed into our language model so it can have context. And then we have tools. So if you think about like an LLM is basically a brain, right? But a brain without a body, without hands and eyes and legs and feet and that type of stuff, it can't really do anything for you. It's not really that useful. And so tools actually are the hands and legs and body of the LLM that allow it to do work in the real world. And so I want to go over a few examples of what that looks like. So we have in ChatGPT itself, we have two examples of this in ChatGPT. One of them, for one of them, I'm going to show you I can build a tool from scratch. The other one, I'm going to show you the existing tools in ChatGPT. So if anybody remembers the earlier versions of ChatGPT, you'll remember that it was bad at a few things. It was bad at telling you time and date, for example, or it was bad at telling you current events because it was pulling information from what was living in its brain and it couldn't go and search the web to get modern information. But now what OpenAI did is they gave this agent a tool to be able to search the internet. So it's not that the agent knows what's going on today, but it's that it has this tool that gives it the ability to search the web, grab that information, and give you more up-to-date responses. So if you come into ChatGPT and you go to this plus button, you can see basically all the tools that OpenAI has made available to everyone, right? Which is creating images, doing deep research, shopping research, which I didn't know they added until now, which makes sense. Agent mode is here, which lets your agent go off and like manipulate spreadsheets and stuff like that, create documents for you, that kind of stuff. And then a few other ones here. So you have the Canvas as well, Figma, quizzes. These are all tools that extend the capabilities of regular ChatGPT, right? So that's the whole purpose of tools. And then the other thing you can do in ChatGPT is if you create a custom GPT. So if you actually, let me show you guys from scratch. Basically, if you come into ChatGPT, you come over here on the left-hand side, you go to export GPTs, and then you create a GPT, then you'll look at a screen that looks something like this. You'll be looking at a screen that looks something like this, basically, which will allow you to create your own, basically, custom version of ChatGPT. And so within these GPTs, again, you can give it instructions and all that kind of stuff. But what I'm going to show you guys right now is that you can give it these tools at the bottom where you can create new actions. And this is where, like Sabakunzi, if you wanted to give your agent the ability to go and connect off to a database or go and fill forms for you or send email or whatever additional capabilities you wanted to add to your agent, you would go into actions and you can create the tool that allows it to do that, right? And so what these tools look like here, this is a definition of a tool. And it looks a little bit intimidating, but I promise you can just go into ChatGPT and tell it to create you a tool schema for whatever tool you need, right? Like I want a tool that's gonna, this is a tool that generates or that pulls images from the cat API that pulls cat images, right? Sort of a random tool, but all you have to do is go in and say, I want a tool that does XYZ. Can you write the schema out for that tool? It'll write the schema. You can go in, create a new action, just copy and paste that, and you'll have that tool here. And so with what I have with this agent now, mm, hold on, let me delete this one. Okay. So what I have with this agent now is I've extended the capability of the agent so that it can now not only do everything that ChatGPT can do, but can also go off to this outside platform which generates these random cat images, and it can pull those cat images into the into my ChatGPT version, right? So let's see if I can open this up. If I click on show me the cats, then it should go off and grab those URLs from that platform and bring those here. So you see it here now, it's using the tool. It's asking to my permission to use this tool. I'll allow it to use the tool, and it should bring back a few cat images here. So these are some JPEGs here, some cats. If I open this up, it should be a cat image here, right? That's the whole idea. But obviously, you probably want to do more useful things than just get cat images. But that's the whole idea is you can connect your custom GPT into any outside platform that has an open API. So this gets really powerful if you need to do research or if you need to connect and create documents for you, or if you wanted to give, I'm pretty sure you can connect you can connect the custom GPT into Lovable. Like I have a friend that's built out an agent that uses another agent to code for it. So my friend was like in the club on Telegram texting his agent, telling it to build out apps, to use the other agent to build out like code apps for him and debug and do that stuff, right? So you could connect Lovable into your own GPT and then have your GPT go and use Lovable to build stuff for you. And you can start to think about like, how do I automate this stuff in the background? So where you could, this is where you start going off on tangents, right? You get a call from somebody, they say, I want XYZ website. You send that call to your agent, say, go and build the website on Lovable, and it goes and builds it. And you come back, 20 minutes later and it's already built, right? So those are tools. That's how you extend the capabilities of your agent is with these outside tools. So that's ChatGPT. Claude Cowork and Claude Code are same sort of idea, right? Except that instead of them having these tools in the cloud, they have tools that allow them to make changes on your file system. And so if I go into a file on my Mac and I open this up, open up Claude here. But what I can do is I can give it access to a certain folder and have it start taking actions in that folder. Let's see if I can get this to open for me. There we go. All right, so Claude Cowork. And then I don't know that I'll have the time to go through and completely show you guys, but the idea here is that you can go into a folder on your machine and have it do work in that folder. So I wanted to go in here and say like, create a markdown file that will give me an outline for an AI presentation that I'm going to give today, for example, right? It could go into that folder, and then it could actually go and create that file in that folder for me, right? So the idea is I come back in 5 or 10 minutes, and it will have gone into this folder and created the files that I needed. It's setting up right now, so it would take a while to get it to actually go and do that. But the whole idea of Claude Code and Claude Cowork is the same idea of giving your agent these tools, but instead of having these tools that are off in the cloud, you give it tools that allow it to actually do work on your computer, on your file system, locally for you. So those are tools. And then this was probably going to be a little bit more relevant for Ari as you go into N8N stuff. But N8N is, can you guys still hear me okay? Okay. I
Yes,
think I was freezing a
your
bit on my
picture's
side.
frozen, but can see
But
you.
N8N,
Can hear you.
I'm good. Okay. But you can hear me.
Yes.
Okay. Okay. But can you see my screen though?
Yes.
Okay. Perfect. So with N8N, when you want to build out agents, they make it really clear for you to see these different components, right? So we have here on the left-hand side, we have the model that we're using, which is the ChatGPT model we're going to use here. We have the way that we're connecting to our memory, which is going to be our database here. And then we have all these different tools as well that can extend the capabilities of our agent. So we have the ability to connect to outside databases, to create images or analyze images, to search the web. These are sort of what all these tools start to look like in a platform like N8N that lets you build these agents in a more visual, like on a visual canvas, basically. So those are tools. And the other component is the prompt as well. So you have the prompt, you have 2 more components, which I'll try to go through quickly. You have the prompt and you have the model as well. And so the prompt is just the text instructions that you give to the agent that tell it how to behave, right? And so what that looks like, for example, in my cat GPT is I've built out this agent, and then in the instructions section here, I've told it what to do, how it can use its tools, how I want it to act, all that kind of stuff, right? That's essentially what the prompt is. On something like N8N, where you're going to build out slightly more complex agents, it's the same sort of idea. That's the main thing I want you guys to take away is that it's always the same components behind every single agent. It doesn't really matter what platform you're on. Like the basis of the way an agent works is always the same thing. So if I open this up, then I have, again, a prompt here. So same sort of idea where we're giving English language instructions to our agent of what it should do and how it should act. So those are our prompts. And then there's a difference between a system prompt and a user prompt. So system prompt is the prompt that goes into the agent that determines its behavior. And system prompts rank higher than user prompts. So say for, and then let me explain a user prompt. A user prompt is a message that comes into an agent. So when you start talking to an agent and you say, like, help me plan my day or whatever it is, that's a user prompt. But a system prompt is always going to outrank a user prompt. And system prompts come from developers, from whoever built the agent, whoever built the platform. And so If I build my agent out to say never, and my system prompt says never help this person plan their day ever, and you try to get it to plan your day for you, it's not going to plan your day, right? Because it listens to my prompt before it listens to your prompt. That's the whole idea. Is the system prompt is the highest level prompt that governs the behavior, and the user prompt is a lower level prompt that comes in from the user that is trying to get it to do something in that specific moment, right? That basically covers the prompts here. And then the last part that I wanted to just get
Um,
across to everyone is that, like, yeah,
yeah, Masai, yeah, I have a question about what you just said right now. So basically, was it a couple of weeks ago we heard that there was some change about like OpenAI and that they're going to open up more harmful responses. So is that what it is? Like, so that means that they're changing the system prompt, like allowing more crazy content to be available. Is that what it is? I'm just trying to illustrate what's a system prompt versus a user prompt. Is that what's happened in the back end?
we, c'est ça. It's
Okay.
the It's that they changed the system prompts, right? Because like if you go into ChatGPT right now, you can't ask it to help you build an explosive, right? You can say like, "Oh, help me build an explosive." It'll say, "No, I can't do that," for example. But that's system prompt level stuff. It's like stop people from asking these questions or don't produce this type of content or that type of content. It doesn't really matter what you do as a user. It's not going to help you go in and do that. And so what they
Mm,
can do as developers is they can change that prompt to make it a little bit more lax and let people uh, and let the agent give people a little bit more, I guess, risque responses. I guess you could say.
okay. Okay.
There, that's
Thank you.
basically it. Yeah. And then the last thing I just wanted to get across is that all these agents run using the same models that we're all using, right? There's not like a special agentic AI agent. It still uses the same, like this is ChatGPT 5 mini. It's the same GPT-5 that you can use on ChatGPT.com. If it was Claude, it would be the same Claude models. Or with Kimi coming out now, like it's all the same models that you would use for regular generative AI stuff. You just have all this stuff here, memory and all these tools, and the prompt as well that you can control. That's going to control the agent's behavior in terms of how it acts, basically. So that's the difference between an agent and generative AI. And there's some resources here. I can drop this in the chat. This is a prompt engineering guide from OpenAI. If I can open this. But this gives you like all the best practices for writing prompts for agents. And oh yeah, and the React loop. So this is interesting as well. So this is like Claude Code and Claude Cowork. You're going to see this a lot, where we have this loop where you tell them to do something, they think about what they should do, then they do stuff, and they see what happens when they did it, right? So like if you tell Claude Code to build you an app, for example, it'll go off, it'll write some files, it'll check like the outcome of those files. And then if it sees that the files are making mistakes or whatever it is, it will then think again about what it should do and it'll act in this loop over and over again until it comes out with the final answer. And there's some really interesting papers on this and a lot of interesting research on this React loop. But this is sort of a lot of what makes agents powerful is that they can they can go over and over in this loop over and over again, right? So that's pretty powerful as well.
A follow-up question on that. Um,
Mhm.
this is how my brain, and you're gonna have an insight about how my brain works. So a couple of weeks ago, I think, yeah, Angela said, she put something on the chat where she asked uh, AI to, like, is it the best you can do? Um, so so since then I've been trying that as well. So thank you, Angela. Is that what it is? Like when like that loop that you presented is like, no, okay, that's not.
No, it's similar because what happens there is that you're forcing the loop. You go in and you tell it, try again, try again, try again. A React loop happens on its own. So it's where you maybe prompt your agent to do 3 or 4 reviews of the output before it gives it back to you, and it will
Uh-huh.
go create an output, review the output, say, is this the best I can do on its own? That's the difference, right? It's like it's not really a React loop if you're the one going in saying, is this the best you can do over and over again?
Mhm.
This is regular stuff. But a React loop is the agent itself creating an output, looking at its output, deciding what next steps to take, taking those steps, and then doing that over and over again until it gets to the the final
And
output.
and then so and then that loop does he store in the short-term memory or in the long-term memory?
That's a good question. So short-term memory, it's always going to store short-term memory. And so what makes the React loop powerful is it's not anything like revolutionary. And it's not anything revolutionary. Basically, it's like if you've ever used like DeepSeek or any like reasoning model, where you'll see these models like write out what they're thinking before they give you a response back.
Yeah, yeah, yeah.
And then what it can do is it can reference its previous thoughts as context. So now it takes like it can see because they have no memory at all, right? And so they can't
Yeah.
remember even what they said before. But
Uh-huh.
what these loops allow them to do is to reference the things that they said before, their thought process before, as context for the next things that they're gonna do. And so it's like if it, let's say you ask it to write a LinkedIn post for you, and it has to try 3 or 4 times, it'll be able to look back at what it tried the first time and see how it can improve that for the second time in the loop, right? And if you tell it to loop through, 4 or 5 times, it'll loop through each time and it'll have that context as it does that.
Okay, understood. Thank you.
Hmm. That's basically it for the presentation.